Question 1. The total time spent machining components is represented by the equation of a straight line. Total time in minutes equals 3n minus 5, where n is the number of components. Draw a straight line graph to represent the time spent machining up to 5 components. You should include labels and axis values. So, the first thing I'm going to do is have a look at that graph paper I've got and the space. There's not much space here to get a table of values, but that's because I don't need to. My calculator will do that for me. If I go into the table and if I enter this equation, well, I don't have t, but that's what the function of x is for. And I don't have n, I'm going to use the x button in place of that. But other than that, it will look the same. 3n plus 5, 3x plus 5. It gives me the option of a second function, which I don't want, so I'll press enter and skip that. I want to start, well, it's good to start graphs at 0, so I'll start at 0. And I want to end at, it says up to 5 components. So I want to be on 5, which I already am. And I'll step up in 1s, that was already entered. Now this gives me a table of values when x, which is equivalent to n, is 0. The function, which is time, is 5. N is 1, time is 8. N is 2, time is 11. N is 3, time is 14. And I can scroll down. N is 4, time is 17, n is 5, time is 20. I need to put these values onto a graph on this paper. Now this goes up to a maximum value of 20 for my time, which is going to be vertical. It's common that time is the independent axis, but in this case time is dependent, the time taken is dependent on the number of components we're trying to make. This graph paper helpfully is in centimeters for each of the big squares. That means if I want to go up to 5 horizontally, because I have 5 components, well, multiples of 5 would fit, 10 would fit, 15 doesn't. So I'm going to go for 10. That would give me 2 squares to the left and 2 squares to the right spare. Before I draw that line in, I want to check my vertical. I want to have 20 vertically. I can't fit 20 centimeters, so I'll have to go for 10. And just like last time, I can fit 10 on with 2 below and 2 above. So that's what I'm going to do. I'm going to give myself a little extra at the top though, and I'll show you why when I get there. So here is where 20 would be, but I just want to include a little arrow on the top there. Similarly, coming over horizontally, 10 would be my 5 components. I'm going to go to 11 just so I can add a little arrow on without that arrow getting mixed up in one of my values. 0, 1, 2, 3, 4, 5. 0, 2, 4, 8. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now it says I need to have labels and values. I'll put the values in first. And that is number of components. Going up my axis here, 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And that is time taken in minutes. That's a label, and a label there, and I've got the values on there. Now I need to plot these values onto my graph. Going back up in my calculator, when x, or rather n, is 0, time is 5. Here's 4, here's 6, halfway between is 5. One, 8. When n is 1, time is 8. 1 and 8. And continuing to enter those values carefully and marking them on my graph accurately until I've got all 6 values. I then take my ruler and connect them and hopefully get a straight line. If any of my points aren't on that line, it might indicate that I've marked them inaccurately, and we need to go back and check that. Question 2. The image shows a steel wedge in the shape of a triangle. Calculate the area of the front face of the wedge. The front face is indicated, this triangular face nearest to us on the diagram. The area of a triangle is equal to half times the base, which is 50, times by the perpendicular height, which is 30. Note, this is at 90 degrees to the base. The height needs to be at 90 degrees. If this was not a right angle triangle, if it was sloping across, the slope length would be no good. We'd need the perpendicular height, which we have in this case, so there's no problem. Putting this into the calculator, gives me an area of 750 millimeters squared. I've not rounded because I don't need to. The units are according to the question, but squared because it's area. Continuing into part 2 of this question, we see that we're asked to calculate the volume of the wedge. Now let's have a closer look at this wedge. What shape is it? If we're calculating volume, we've got formulae for cylinders, spheres and cones, and this isn't any of those. This is in fact a prism. It's a prism because if I sliced the front off and then sliced the front off that and again, each time the slices would be the same shape. There'd be this front face if I sliced it directly off the front each time. That is what makes it a prism. Now a prism, the volume is equal to the cross-sectional area, which is that front face, of 750 that we calculated in the previous part and we can thus use in this part, multiplied by the perpendicular height. Now, earlier I referred to this as the perpendicular height, and this is the perpendicular height of the triangle. But this distance of 5 millimeters here is the height that is perpendicular to this face. It's about what it's perpendicular to, and that means the perpendicular height of the prism is 5. Putting that into my calculator, I've already got the 750, so I can just press times 5, gives me a volume of 3,750 millimeters cubed. And again, I've not had to round that, so I've just given it directly. Question 3. Two lines have been drawn by a CNC plotter. These lines are represented by the following simultaneous equations. Bam, we know exactly what we're doing. Here they are. 4y equals 3x minus 9 and y equals x minus 11. Find the coordinates x, y where the lines cross. If I solve these simultaneous equations, I'll get a value for x and a value for y, and that is what I can use in my coordinates. So the first thing I'm going to do is I'm going to label this equation 1 and this equation 2. Looking at the equations, if I want to make the coefficients of y match, I would have to times equation 2 by 4, because 1y times by 4 would give me 4y, and that would match. Alternatively, if I wanted to make the x values have matching coefficients, that's a 3, that's a 1, so I could times equation 2 by 3. That's what I'm going to do. I'm going to take equation 1 as it is, and I'm going to times equation 2 by 3. Y times by 3 is 3y. X times by 3 is 3x. Minus 11 times by 3 is minus 33. And now my two equations have matching coefficients for the x term. Since they're both positive, I need to subtract these two equations from each other. 4y minus 3y is 1y, which I will write simply as y. 3x take away 3x cancels out. Minus 9 take away minus 33. Now, if you're unsure about that, you can use your calculator. Negative 9 take away negative 33 gives us 24. Now that I've got a value for y, I'm halfway there. I'm going to use this by substituting it into my second equation. I'm using the second because it's got a nice simple term for y. If y is 24, then instead of y, I will put 24, and the rest of it continues as x minus 11. So, 24 is y, x minus 11, x minus 11. Looking at this, if I add 11 to both sides, I'll get 35 over here and x over there. I've now found the values for x and y. Before I write my answer, there's a number of ways that I could check this. The first is I could do it manually. I used equation 2 for my substitution, so I'm going to use equation 1 for my check. 4y, or 4 times y is 24. 3x, x is 35, so 3 times 35 minus the 9. On my calculator, 4 times 24 equals 96, and 3 times 35 minus 9 is also 96. That shows that my solutions of 24 and 35 are correct. So that's just my check method there. Another way that I could check my work is using the calculator. If I go to Menu and down to Option A, I get the option of solving simultaneous equations, Option 1. X and Y are my two unknowns, so I'll select two unknowns. Now if you look at this, I've got X plus Y equals number, and that's not how these are rearranged. I need to rearrange these equations so I can enter them into the calculator. If I subtract 3x from both sides, I'll get negative 3x, and I've still got that positive 4y there, and I'll just have the minus 9 on the right. Similarly, subtracting x in the second equation, minus x, I've still got the positive y and negative 11 over there. Entering all of these into the calculator, the first coefficient, negative 3, positive 4, negative 9, negative 1, positive 1, negative 11. And that gives me a value for x, that's 35, hitting equals again, y is 24. So I can use the calculator to check it. Now, I'm absolutely certain my answers are right, so let's write them in as the answers. Remember, I was told to give coordinates x first and then y, so my answer is 35, 24. There is an alternative way of doing this question. The method of simultaneous equations I did here is known as the elimination method, but you could also do the substitution method. In this instance, 4y is equal to 3x minus 9. Here I've written that out, but I've swapped the y for x minus 11, because y is equal to x minus 11. That's the substitution that I've made. I've substituted y equals x minus 11 into this y here inside the 4y. So all of the x minus 11 is being times by 4. Expanding, I get 4x minus 44, and this side stayed the same for now. If I subtract 3x, I've just got the minus 9 left here, but this 4x becomes 1x. And then adding 44 gives me the same values that I would expect. Now that I know that x equals 35, y equals x, well x is 35, so y equals 35 minus 11, so y is 24. And I write my answer in the same way, and of course I could have done those same checks that I did as well. Question 4. The diagram shows a metal circle of steel where a sector has been marked out so it can be cut. And here's that sector. Part 1, convert 70 degrees into radians. Okay, 70 degrees. If I want to convert it into radians, I need to, there's a number of ways I can do it. Ultimately, this is one of them. I could divide by 360 and times by 2 pi, but that 2 and the 360 can cancel to give me pi over 180. However you do it, show you're working, but with the calculator you would get 1.2217 and so on. It doesn't specify how much to round to, so I'll give them 3 different figures. And don't forget to show units and the degree of accuracy that you've rounded to. So I've converted 70 degrees into 1.22 radians to 3 significant figures. In part 2, I'm asked to calculate the arc length of the shaded sector. Now the arc length, that's this length here. However, the formula for that, given in the formula sheet, is S for arc length equals the radius times by the angle when the angle is given in radians. So the radius, if we look at the diagram, is 40 millimeters. So 40 times by, now at this point, if my calculator has still got the exact value in there, if I had done 70 times by pi over 180, then I would have this exact value. If I keep that there and times it by 40, let me just make a note of what I'm doing. I've used the exact value from the calculator in the calculator. I'm going to times that, the answer, times by 40. And that gives me 48.869, etc., which to 3 significant figures for my answer I can give as 48.9. S, the arc length, equals 48.9 millimeters to 3 significant figures. Now, if instead of using the exact value that you had stored in your calculator, you had used this rounded value, that's acceptable, but it would have given you an answer of 48.8. Question 5. The diagram shows a stamped angled plate. Calculate the length of dimension x. So looking at this, it's a triangle, so I'm thinking some form of trigonometry is going to be involved. There's no right angle, so it's a scalene triangle. That means it's either the sine rule or the cosine rule. I now need to look for either pairs of opposites or the included angle. This angle and that side are opposite, this side and that angle are opposite. Pairs of opposites, it's the sine rule. The sine rule, if I want to find a side, I'll have that on top. X divided by its opposite angle but the sine of that, and the other side divided by sine of its opposite angle. Now already I've got 2 marks, one for the correct substitution and the first mark in fact for the fact that I know it's sine rule. If I had written the sine rule or written out the sine rule, that would also have been enough for the first mark even before I get here, but the substitution gets me the mark anyway. Now for the third mark I need to rearrange. X will be equal to 160 sine 43 over sine 73 degrees. I've brought that sine 43 up onto the numerator over this side. That's the third mark for my rearrangement. Using the calculator to evaluate this gives me 114.10, etc., which means that x is equal to 114 millimeters to 3 significant figures. Apologies that that last bit was off the bottom of the screen. There it is now.